Okay, so in our lesson today, we're going to cover this in more than one day. It takes more than one day to cover this lesson. We're just going to start out with talking about ratios, and then on the back side we'll talk about rates, and then starting tomorrow, going on tomorrow, we'll talk about some more. So ratio of A to B is typically written as a fraction, A over B, just like we did in that warm-up exercise for today, that exploration worksheet. So the ratio of A to B is typically written as a fraction, but you also might see it written with a semicolon or a colon between it. So A colon B is another way of reading a ratio. You're comparing A to B. Now, one of the things that's really important in a ratio, because it has ratio, a fraction bar shows division. There's really division going on. What really matters is the order, because we know that when you divide 20 by 10. What is that? 20 divided by 10. 2 is not the same as 10 divided by 20. What's 10 divided by 20? The decimal. It's what decimal? 0.5, yeah, or 1/2. So they don't mean the same thing. So order matters in ratios. So we have to be really careful about that. So we're going to learn how to set up some ratio relationships and talk about what they mean. So we have your football team won 8 out of 15 games. What was the team's ratio of wins to losses? It's saying it right here. It's telling us we want to compare it in this order. Wins gets compared to losses. So we have to keep it in that order. So did they tell us how many wins there were? Yes. Okay, how many are there? 8. Okay. Did they tell us how many losses there are? No. Well, what other information did they give us then? Yeah, there were 15 games total played. So can we figure out how many games they lost? What do we have to do? Yeah, we have to take 15, subtract the 8 wins from it, and that should tell us how many games they lost. So go ahead and do that in your notes. What is 15 take away 8? 7. So 7 games were lost. So now, this is how they wanted us to set it up in this order. Wins to losses. So what are we going to put upstairs? 8. There were 8 wins over 7 losses. Okay. And now we're going to say the win to loss ratio is, if we could simplify it, we will simplify it. Can it be simplified? Yeah. One thing we're not going to do is we're not going to change them to mixed numbers. Because it'll make more sense to say it this way, that there were 8 wins to 7 losses, than to say there was 1 and 1, 7 win to 1 loss. So we're going to leave it as 8 sevens. We're going to say that's our final answer. We're not going to simplify that anymore. Okay, so again, we've got to make sure we pay attention to the order and what they're asking us for. You don't just take the numbers that are in the problem and stick them in and call it good. Say, oh, well, there's a number 8 and there's a number 15, so I'll put 8 over 15. There's my answer. What would 8 over 15 compare?
8 out of 15.
8 what?
8 wins out of 15 games.
Yeah, 8 wins out of 15 games. That's what 8 over 15 would compare. So we have to make sure whatever comparison they're asking us to make, we're making the correct one. Okay, well, sometimes ratios can be simplified, which we discovered today in the exploration. So let's do this one and then see if we can simplify it. The basketball team won 12 games, or lost 12 games, I'm sorry, and won 16 games. Find the ratio of wins to losses. So again, we can't just say, okay, there's 2 numbers in the problem, just haphazardly set up a ratio. We need wins to losses. And so what will that be? What's going to go on top? 16. They won 16. And how many did they lose? 12. This time we don't have to calculate it. They gave it to us. So the ratio of wins and losses is 16/12, but can it be simplified?
Yes.
Right?
Yes.
So what can we simplify that to? So that can be simplified to 4 over 3 because both of them are divisible by what? 2, but then they're also, so we can first divide by 2, And we're gonna get, but then we don't get 4, do we? We get 8 and 6. So what do we have to do?
Simplify again.
Then we have to divide again. They're still both even numbers, aren't they? So 8 divided by, so in reality, we can go right to work dividing by 4. They're both multiples of, I didn't do a very good job with my division sign there. They're both multiples of 4. So we can divide by 4 right away, and we see that we get it simplified to 4/3. So the wins to loss ratio is 4-3. Our ratio should show that they won more games than they lost. How does it show it? Just by saying 4/3. How does it show that they won more games than they lost, Cameron?
Because 4 is on the top and 3 is on the bottom.
Okay, and what happens is, what is true about 4/3 if we did simplify it even further? Go ahead, Cameron.
It's greater than 1.
It's greater than 1. So that tells us that yes, the wins should be greater than the losses. And we set it up right. Okay, so therefore, this is just for our notes. Therefore, the win-to-loss ratio can be stated in simpler terms. For every, instead of saying for 16 wins, we can say for every 4 wins, there were 3 losses. So it's just as simple, it's just kind of like stating it more simply. It's not saying they only played 7 games. It's just saying that every time they won 4 games, they had 3 losses to go with it. In this combination of 16 wins and 12 losses. How many games did they play altogether, by the way?
28.
28. Yeah, 16 plus 12, they played 28 games altogether. So we could also break it down and talk about it in chunks of, for every 4 wins, there were 3 losses. Okay, I want you to set up the ratio for the next one. 9 to 72. What would that look like? 9 over 72. So we'll write it as a fraction. Can that be simplified?
Yes.
Okay, what can we simplify it with?
1/8.
Okay, what are we going to divide each of them by? Let's show it in our notes. We're going to divide by what?
9.
9. They're both multiples of 9. And of course, we should recognize that easily after all the multiplication practice we've done, right? So 9 divided by 9 is 1, and 72 divided by 9 is 8. As soon as we see that 1 upstairs, we know it can't be simplified anymore, right? So here's our ratio simplified, 1/8. Okay. How about our next one? Is it already set up as a ratio?
Yes.
Okay, as in the fraction form. Okay. So what can both of those be divided by?
3.
They're both divisible by 3. Okay, let's start with 3. Sometimes it's okay if we take a slower process to get there. What's 36 divided by 3?
12.
12. Okay. What's 60 divided by 3? 20. How do I know for sure that I can still go further yet? They're both even numbers, so if it's an even number, it has to be divisible by 2. Okay. So what do you want me to divide by next?
4.
Oh, you want to do 4. Okay. They're both multiples of 4. Okay. And so what is 12 divided by 4? 3. And what's 20 divided by 4? 5. Okay. Anybody feeling like we can simplify even more?
No.
You think we're done?
Yeah.
Okay. We are done. They're both prime numbers, and so we cannot simplify that anymore. Okay. Any questions about setting up ratios, simplifying ratios? Anything you don't understand about ratios before we move on to rates? Okay, then let's go to the back side where we are going to talk about the rates. So when we have a rate, actually what we have is 2 things being compared, but they're measured in different units. Okay, so if A and B are measured in different units, so we have a ratio. A rate is really just a ratio, but they're measured in different units. Then we say that ratio gets to be called a rate. We have lots of rates that go around in our world around us every day. Anybody give me an example of a rate? Cameron?
Miles per hour.
Miles per hour. How fast you drive is a rate.
FPS,
FPS, what's that stand for?
frames per second.
What?
Frames per second.
Frames per second, and what's that about? Dakota, what's that rate represent? Frames per second of what?
Computers and cameras on
When we have
video.
computers, cameras, when we have images, okay? So there's lots and lots of reasons. Does anybody have a job in here? Okay, how do you get paid? So many
Hour.
dollars per hour, right? Yeah, you make so many dollars per hour. So we have lots of rates. When we have a unit rate, which is what we're going to be working with today, when we have a unit rate, that means we get our rate simplified so that it is a rate per one given unit. So when we do miles per hour, we don't typically talk about that we're going 120 miles per 2 hours, do we? We would say instead, we were going 60 miles per hour, which is per 1 hour. So we simplify it down and make it into a unit rate, okay? So the example that I want us to put here is like miles, that one I just talked about, miles per hour. So we go so many miles per every 1 hour, okay? So, and that's typically written MPH, isn't it? We don't typically write out the whole, all the words for it. Okay, now, we have to be really careful today when we're setting up these problems where we're working with unit rates. Do you ever hear anybody say this? Half an hour per 30 miles.
No.
No, we don't change it around and say hours per mile, do we? So there's like a common way that we would say, when you get paid by the hour, do you say so many hours per dollar? That's how much you get paid? So many hours per dollar? And there's like a sensible way to state it, isn't there? So again, order matters in our unit rates too. We want to make the comparisons reasonably, sensibly, something that we're used to hearing probably. So here's one where we're going to find a unit rate. A plane flies 1,200 miles, 1,200 miles in 4 hours. Well, do we want to set up miles over hours or hours over miles? Which makes more sense?
Miles per hour.
Miles per hour. We want the miles to be on top, and we want the hours to be on the bottom. Miles per hour. Fraction bar can also stand for the word per. So the first decision you always have to make is which way does it make more sense to set it up? Again, you don't just haphazardly put those numbers in the problem and go to work. You want to make sense of it. So we need the 1,200 upstairs and the 4 downstairs. And in these, we're actually going to divide them out. So what's 1,200? In fact, let's put that right here in our notes. We're going to do 1,200 before we actually do it. 1,200 divided by 4 is, Cameron?
300.
300. So the label would be miles per hour. Only planes should be going that fast, right? Okay, so 300 miles per hour. So when we're doing unit rate, we do actually divide it out, because it's going to be per 1. Okay, you mow 3 lawns and earn $45. Does it make more sense to figure out how many lawns you did per dollar, or how many dollars you got paid per lawn?
Per lawn.
Dollars per lawn. I'm thinking that one probably makes more sense, doesn't it? Okay, let's try it. So we have dollars. We need our $45 upstairs, and our 3 lawns downstairs. And I want you to use words in your setup. I want you to do this like I'm doing. It'll help you be more successful. Use the labels. Because this says we're going to get dollars per lawn. And I'm thinking that makes better sense to me. I want to know how many dollars I'm going to get paid for every lawn I do. So now that's going to become a division problem. 45 divided by 3, which is, anybody know what 45 divided by 3 is? 15. And it says 15 what? What was upstairs? $15, so $15 per lawn. There's really no abbreviation for per lawn. PL, we don't know what that means. We're gonna have to write out the words. $15 per lawn you got paid. Hope they were small yards.
So can you imagine?
That would be a ripoff.
Okay, I want you to decide, I want you to well, let's do this first. Let's say cards per dollars or dollars per card. I want you to write that down in your notes. And then I want you to decide which way do you think we should use it. Circle the one you think it should be. Riley, what you say? So it makes more sense to you to say how much you were paying per card than how many cards you got for every dollar? How many of you agree? Makes more sense to say, you know what, I want to know how much I paid per card rather than how many cards I got for every dollar. Yeah. Okay, so what's our setup going to be then? With labels in them, I want you to tell me what my fraction is going to be that I'm going to set up. Mia? Okay, you got this down?
Yes.
Okay. Then if you agree with this, what's going to go on top? The dollars. What's going to go on top? 15. $15 per how many cards? We started with 6. Yeah, we're going to figure out how many there are. How much it is per one card by dividing. But right now it's not 1, so we have to put that 6 in there, and we say 15 divided by 6 is 2.5. Okay. 2.5 what? $2.50. So we want to put a 0 behind that 5. $2.50 what? Per card. Yeah.
I got 5 and 2.
You what?
I got 5. I divided them both by 30 instead of 6. And I got 5 and 2.
Okay, so you have 5 over 2, but then we're gonna take that out, so it's per 1. Right now, Dakota, when you do that, you just have 5 per 2. We want it per 1. So that's why we have to take it further yet. So you'd have to divide both the top and the bottom by 2 yet. So you have a 1 downstairs, and then it would be the same thing we have, $2.50 per card. So again, tomorrow when you ask me, Mrs. LeGrand, is this acceptable? Would somebody do this for me? What is 6 divided by 15? What is 6 divided by 15? What is it? No, what's 6 divided by 15? 0.4? Okay, so that would mean then what? If we changed it around and we had it this way, 6 cards over $15, and we divided that out, Hunter says that is 0.4. That's 0.4 what?
Cards.
Cards per dollar.
It's a ripoff. You can't get the whole card.
Well, it's 2/5 of a card for $1. Is that typically how we want to hear we're buying our, No. So that's why we set it up this way, because this makes more sense to know how much we're paying for every card, doesn't it? So again, tomorrow when you ask me, is this going to be a correct answer, Mrs. Gren? 0.4? I'm going to say, no, doesn't make sense. We don't want to know how many cards we get for every dollar. We want to know how much we pay for every card. Okay, any questions?